So this is a continuation of the material in Chapter 7 involving built-in functions. And last time we looked at a lot of statistical functions such as the mean, the median, the variance, the standard deviation, the minimum, etc. In this case, we're going to look at slightly more mathematical functions. Let me start out by setting a vector x to the integers from -1 up to 3. So once again, you can see in the upper right-hand window that x has been set and -1 through 3 are being placed into x. First function I'm going to look at is the square root function, and you can say the square root of 9 or the square root of 49. So it can be used in the case of a single argument, but it can also be called with a vector. So if we say the square root of x, now what we're going to do is when it takes the square root of -1, it will get not a number because you can't take a square root of a negative number. And in the case of the square root of 0, it'll get 0, and then square root of 1 is 1, and here is the square root of 2 and the square root of 3. Now one thing to notice is if I say the square root and I put in a vector, let's say the vector is 1, 9, 81, and 225. Notice that when R can display the numbers, I put in all perfect squares there. When it can display them as integers, it will do so. It won't bother with decimal points. It won't give them to 7 digits, whereas in this case, it gave them to whatever number of digits was showing at the time, which in this case is 7. So if I go back to that previous command with an up arrow, and I throw in one more number, let's say 17, now what it will do is it will display all of those numbers to the same 7 digits. So it will be consistent within the values of a vector, but if it can avoid throwing in extra digits or trailing zeros or anything like that, it will do so. Here's a couple more functions. In addition to the square root function, you can say I want the absolute value of x, and in this case there is the absolute value. There's another function called the sine of x, and what this will do is it will give you a -1 if the sign is negative, it will give you a 0 if an element is 0, and it'll give you a +1 if the sign is positive. Here's another one, which is the log of x. Now when you see log, you might be thinking of the common logarithm, but this log right here is the natural logarithm, so this is log base e. And once again, when you put in a negative value into the natural logarithm, it'll give you not a number. When you put a 0 in, it'll come back with -infinity. The natural log of 1 is 0, and here is the natural log of 2 and the natural log of 3. There are other logarithmic functions. For example, if you want to say log 10, that will give you log base 10. You could put in 100 and you'll get 2, or you could put in 1000 and you'll get 3. There is also a log 2, which is log base 2, and for example, if I were to put 64 in there, it would come back with 6 because 2 raised to the 6th power is 64. There is also e raised to the x power. And in this case, this first number that you see here is e to the -1. Here is e to the 0. Here is e to the first, which of course is just e. And here is e squared, and here is e cubed. In addition, all of the trigonometric functions are in there. For example, if you want the cosine of pi, you'll get a -1. If you want the cosine of 2 pi, you will get +1. You could also say, for example, cosine of x, and you will get the cosine of -1, cosine of 0, cosine of 1, cosine of 2, cosine of 3. Keep in mind that it is accepting those arguments in radians. There are also inverse trigonometric functions. So if you say, what is the arctangent of 1? It'll come back with 785. Now, for an arctangent of 1, you're expecting 45 degrees. But in fact, this is returning it in radians. And so if you were to check, pi over 4 turns out to be what is being returned here. You have hyperbolics as well. So if you want the hyperbolic sine of, say, 7, it'll come back and tell you that's 548. There is also a factorial function. So if I say factorial of 3, we'll come back with 3 times 2 times 1, which is 6. In addition, if you say factorial of x, it will once again complain that you cannot take the factorial of -1. However, the factorial of 0 is defined to be 1. The factorial of 1 is 1. Factorial of 2 is 2 times 1. Factorial of 3 is 3 times 2 times 1. It will give you a warning message when you run into this not a number for the factorial of -1. You will also consider it a little bit strange that it's calling this other function called the gamma function, but that's simply because the gamma function is a generalization of the factorials, and it was called in order to produce these numbers. You can also get the choose function, and I will use the number of poker hands, that is, out of the 52 cards in a playing deck, choose 5 of them where order is not important, and that will give you 2,598,960. If you want to know how many 10-card poker hands there are, you just replace the 5 with a 10. 52 choose 10 gives you a much bigger number of 10-card poker hands. That's it for this section, and in the next section we'll move on to truncating and rounding.